Hi, dear students. My name is Dr. Himmat Alisha. Welcome to the course Data Analytics 2 and today's lecture number 3. And trust me, this is where things start getting really exciting. Today, we are diving into a very powerful concept in data analysis, time series analysis, or it is also known as time series forecasting or prediction. Why is it so important? Because time is everywhere, whether we are tracking daily stock prices, hourly website visit or usage, monthly sales, or yearly climate data. We are dealing with the data that changes over time. Time series analysis help us to understand how things changes over time. Even better, it helps us to predict what might happen next, tomorrow, in the future, after 1 week, after 1 month. For example, think about knowing tomorrow's sale, next month electricity usage, or traffic, looking at just past data. That is the power of time series analysis. So today we are looking at what time series data is, why it is different from the regular data or normal data, and how it is used to solve real world problems. Whether you are into business, finance, health, climate, and even sports, time series is everywhere. And this lecture will give you tools to start using it. So please keep watching. Next, we look what does time series data looks like. Let's take a moment to look at what time series data actually looks like. At its core, time series data is just a list of value measured at different point in a time. It's usually organized into two columns. Number one column would be time, like days, months, or hours. Minutes, seconds can be possible. So and then we have values like sales, temperature, and our website traffic. Sales might be in the monetary form, dollars, euros, and in different monetary forms. Temperature might be Celsius and Fahrenheit. And website traffic, number of citations, number of looks on the website, count the number of. Next, we have example we can see from the table. There are two columns. One is called date, and other is called the sale on that data. So imagine we are tracking daily sales. We record the amount of sold each day. That's it. This structure is a time stamp and a measurement. It's what defines time series data. It may look simple now, but this format lets us spot patterns, see trends, and even make future predictions. Everything we will do in the time series analysis start with this kind of table. So first we look at the data. We try to figure out patterns, trends, and future prediction from data in a series format on spots like with a time stamp. Dear students, now let's take the same time series data we just look at in the table form and turn into a line chart you can see over here. As you can see here, each point represents the sales on a specific day or date. For example, dates are in August, from 1st to 7th August. Then, when we connect the points, we get a clear picture of how sale changes over time, over week. This is the power of a visualization time series. It turns a list of numbers into a story. So now we can easily follow the story. For in this example, we can already see patterns. Sales are steadily increasing over time. This upward shape, what we call trend, and it is one of the key things we look for in time series analysis. So we already have two important things in the line chart. One is pattern, other is called trend. Later on, we will see how charts like this help us to detect trends, seasonality, sudden spikes, and more, and even make predictions. We will check what are the anomalies, lower values. There is a limit of the lower values, and there is a maximum values, and there is a limit for the maximum values. These are called the anomalies detection. So this is like a little advanced topic. I will try to cover this in this lecture 3. But for now, just notice how much easier it is to understand the data when we look at it in a chart like this.
Let's see one example. Here we see 5 years time data series of such interest for the word diet. This is synthetic data, but it is not realistic and help us see the structure time series analysis tries to capture. Number one, we see the seasonality. Notice that sharp spike that happens every January. So month of January is always the start of the year. So that lines up perfectly with the New Year's resolutions. When people are more motivated to search for word diets. This is classic example of seasonal effects on the on data. Now let's see holiday dip. Now look at December. Each year, such activities falls to lowest point maybe. That makes sense. During the holidays, people are less focused on the dieting. This repeats low is another clear seasonal signal. Then earlier we saw diet searches where the patterns were regular, strong seasonality, a slow trend, and sometimes noise. Financial data in this slide looks very different. This is example of Globex Corporation. This chart shows monthly closing price for Globex Corporation from data from 2015 to 2025. You can see clearly in 2020 there is a big drop like a pandemic shock, then a rebound in 2022. So in year 2022, the market had another weaker dip. That's a change of the phase. Big ups and down come in groups. Busy times stay busy, calm times stay calm. The average price and the size of swing change over time. The series does not stay steady. In conclusion, the forecast we need flexible models that can handle changes, not one fixed formula. So, compared to diet search, financial data is more messier.
A third example we see on the screen is a quarterly earning for H&R Block Company focus on text preparation. So we can see on the x-axis we have earnings in millions USD, and on y-axis we have years. We can clearly see the data between 2010 and 2025. So it's around 15 years data. The pattern is very striking. Most of the earnings happen in the spring quarter.
So when people file their taxes, when they file their taxes, other quarters have very low earnings in comparison. We also notice a slight upward trend over the years. So it's long term and it's like a one way trade. So any of forecasting models here accounts for strong seasonality. Otherwise, the prediction will fail. So this is totally different slide, different chart from the two others. There's only spike in a particular specific time of the year. Otherwise, it is low, very low. Okay, so next we see multiple series, crude oil, WIT, and Brent monthly example. This is unlike the earlier example, this is a multivariate time series. So we are looking at interactions between two related markets. We compare the performance of WTI and Brent crude oil from year 1996 to 2024, means around 28 years of data has been compared. So on the x-axis we have a price in USD per barrel oil, and then we have a date on y-axis. In orange color we can see WTI crude, and in light blue we see Brent crude oil. So here we have two time series together, price monthly and the dates. Notice that how the two series move closely together. Both responds to same global supply and demand shocks. In the lines, diverse a little due to transport cars or regional differences, but these spread usually close again. We also see clear regimes. The sharp spike in 2008. You can see spike over here in 2008. The, the crash in 2020 and the recovery that followed. So this chart makes a very clear regime shift and co-movement, very clear, and WTI and Brent track the same global forces, which short-lived gaps between them. Okay, so let's dive into what is time series data. Time series data is all about the sequence of observations collected at successive point in time. A key thing to remember is that the order of the data is very important and it matters a lot. What happened yesterday can influence what happens today. So common example include daily stock prices, monthly sales, monthly sales revenue, annual temperature record, and we can use time series analysis data to understand patterns, especially trends, seasonality, noise, cycle, and we can also forecast future values. In this slide, we are covering how data really looks like a time series data example with a time stamp associated with it. So we have a sales column with a time and the date, other two columns. So this is like a hourly based time series data. Time series data are observations recorded sequentially at equal spaced time intervals. And as you can see in the table, it's like recording cell units each day for a week, showing how things changes over time. Dear students, your task is to identify the type of time series. So, time series data can be recorded at a different frequencies. It can be hourly, daily, weekly, monthly, quarterly, or yearly. So, your task is I will provide you three example table next in next slides. So you have to identify the frequencies of each series. For example, in table 1 and table 2 and table 3, you have to identify what is the type of the series, like is this hourly, daily, weekly, monthly, quarterly, or yearly data. Same way in table 2, same way in table 3. So you have to answer the questions in comments below. Okay, dear students, let's move to the important topic of the time series analysis, that is characteristics of the time series data. Time series data has several key characteristics that include chronological order, sequential dependence, temporal component, constant frequency, dynamic nature, stationary and non-stationary data. So our focus will remain main topic temporal component. Basically, it is a pattern like trend, seasonality, and noise. So basically, one may ask, what is characteristics? What do you mean by characteristics? Characteristics means distinctive features or qualities that defines time series data. These are essential aspects that makes time series data unique and help us to understand and analyze the data properly. Okay, let's start with the first key characteristics, chronological order. This means that observations are recorded at regular time intervals and their sequence is maintained chronologically from the earliest to latest. Without proper timestamp, data cannot be considered a proper time series data. For example, data stock prices recorded every trading day follow this chronological order. An example of chronological order is listing data from January 1st, 2020, then January 2nd, 2020, and followed by January 3rd, 2020, and so on. So listing them out of the order like January 3rd, then January 1st, then January 2nd would break the chronological sequences. In the example 2, we see time series data for the daily sales units from day 1 to day 3. So correct chronological order would be day 1, day 2, and day 3. So in a sequence. Incorrect shuffle order would be like day 2, then day 1, day 3, which is wrong, which breaks the chronological series. So keeping chronological order is very important because it defines the structure of time series data. So why chronological order matters? Chronological order matters because time series data relies on temporal dependence, where past values influence future values. Shuffling the order destroys these temporal relationships and misrepresents the process. Therefore, it is crucial to always preserve the natural time order before modeling or plotting the data. So, this slide compares correct chronological order with incorrect chronological order graphically. The top graph shows the data in proper sequence, revealing a clear trend from one point to another, and the bottom graph with the shuffled data distorts the actual progression and makes it difficult to identify the meaningful pattern. This highlights the importance of maintaining the chronological order for accurate time series analysis. And now let's dive into a fascinating concept of sequential dependence. This is a key characteristics where current observation are significantly influenced by the past value. Understanding this dependence is a crucial for building a powerful forecasting model. For example, today's temperature is likely closely related to yesterday's temperature. And this relationship is what makes time series analysis so valuable. So basically, we are trying to build a relationship current and past data. So we saw just in last slides that there was a chronological order. Chronological order defining the structure, and the sequential dependence defines the relationship between past and current values or data. Another example of the sequential dependence is think about stock prices. The prices of stock today is highly influenced by the by its price history. This dependence allow us to build models that can help predict future price movements. It is sequential nature of data that makes time series analysis so powerful. So before move into the detail of the questions, first, what we do if we have some incorrect chronological order in data. So we need to apply sorting to make it time stamp sorting according to the date. So sorting the data chronologically is the key process to correct the shuffled order. So we need to arrange data point based on their time stamp, ensuring that they are in correct sequence from the past to present. This step is critical for maintaining the temporal dependencies and allowing for accurate time series analysis. So next question is what is difference between chronological and sequential orders or sequential dependencies? Chronological order refers to arranging data according to the time it occurred from earliest to latest, while sequential order, on the other hand, refers to the order in which observations appear and can imply dependency between them, where each observation is related to the previous one, regardless of strict chronological time. In time series analysis, chronological order is crucial because the timing of each data point matters. Next, we are moving into the exciting world of temporal components in time series analysis. Understanding these components is crucial for accurately forecasting. A typical time series essentially consists of four main parts: trend, seasonality, cycle, noise. So we will explore each of these in more detail in part 2 of the lecture, but this gives you fundamental overview. So first of all, what is a trend? Trend which represent long-term direction of the data. It might be upward and downward. So some sort of trend going on. And then we have a seasonality. The word seasonality means it repeats, which captures regular repeating patterns occurring in some seasons. For example, ice cream sale comes in summer. Use of air conditions is due in summer also. So seasonality is second. Third, we have a cycle. Cycle is referring to a long-term irregular movements like sudden shocks, pandemic times, and sudden zigzags, but long term. Then we have a last noise. Noise is which is a random variation in the data. Means it's coming nowhere. Sometimes it is a higher, and sometimes it's a lower. Next, we have a constant frequency characteristics of time series data. The main idea is that the data should be collected at regular interval or consistent time intervals. This consistency is crucial for accurate analysis in time series data. If there are missing values or if there are irregular gaps in the data, it can lead to misleading results. The example provided here is a weekly unemployment claims, which are published consistently every Thursday. Next, we see the graph. We can see there are two types of the data. One is how constant frequently data provides a clear picture over a time, while irregular data with missing points makes the analysis more difficult. So there are two different colors used. One is blue, one is orange. Next, we have example. Another example is collecting hourly temperature reading from a weather station. Collecting these reading every hour provides a constant frequency data set. If there are gaps in a data, like several hours, it becomes more difficult to analyze and can change the result or accuracy of the predicted future values. Now let's dive into important concept dynamic nature of time series. So dynamic nature refers to the fact that time series data can change significantly over time, often influenced by external factors such as shocks, policies, or unexpected events can disturb the usual pattern and trend in the data. For example, earthquakes, COVID, pandemic, a certain protest, change of government. So these policies can influence externally on the data. For example, COVID-19 pandemic caused sudden drops in air travel, you can see from the graph, drastically in 2020 and 2021, altering the typical time series pattern for the industry. Next, we have the characteristics of time series data, stationary and non-stationary data. Now let's talk about the difference between stationary and non-stationary data. So first, stationary data. Stationary data has properties like mean, variance, and autocorrelation that stays constant over time. Some specific time period they remains constant. For example, daily temperature deviations from the average. On the other hand, non-stationary data has properties that changes over time. Stationary doesn't change, non-stationary changes. For example, stock price with a trend and volatility in is non-stationary changing over time. Understanding this difference is crucial because many forecasting models assume data is stationary. If your data is not stationary, you might need to transform it like differencing or log transformation. So, how to determine if data is stationary? You can look at plots of the data and use statistical test. Stationary data often has consistent mean and variance over time, while non-stationary data might show trends, seasonality, or changing volatility. For example, a plot of stationary data might look like a random fluctuation around a central level, where non-stationary data could show a clear upward or downward trend. Let's see the example in next slide. Okay, so let's check the example of stationary and non-stationary. So we have two different charts in front of you, one in blue color, other in red color. So blue color represents stationary series with white noise, and red color represents non-stationary series, random walk. We have x-axis, on x-axis we have value, and y-axis we have time. So understanding stationary is critical in time series analysis. Stationary data has constant mean as previously we learned. The constant means, variance, and autocorrelations over a time, like white noise shown here. Non-stationary, on the other hand, data has statistical properties that changes often. For example, trend or varying volatility as seen in random walk example. This distinction is very important. Many forecasting models assume stationary data. To handle non-stationary data, techniques like differencing or log transforms are often used to make the data stationary before modeling. So one question may arise is there any mid-term in between stationary and non-stationary? While we often categorize data as strictly stationary or non-stationary, so there's no third type. In reality, some data can exist properties that fall somewhere in between. For example, some series might have periods of relative stationary followed by a shift in the mean or variance, or they might have slowly evolving trends. There are sometimes referred to as locally stationary or piecewise stationary series. Handling these types of data requires more complex methods that can adopt in different time series analysis. So before conclude the part 1 in time series analysis, let's check objectives of the time series analysis. So as we know, time series analysis, a statistical technique used to extract meaningful insights about patterns and trends from time ordered data. There are two key objectives of the time series analysis: understanding the past and forecasting the future. The first objective is to understand the past by identifying historical patterns, trend, structure, like analyzing past sale to find seasonality. The second objective is to forecast the future using past patterns, predict future outcomes, for example, predicting next quarter demand or forecasting tomorrow's customers, tomorrow's weather.